Next question is, a body starts from rest at A and moves with a uniform acceleration A in straight line. T seconds after, second body starts from A and moves with a uniform velocity V in the same direction line. Prove that the second body will be ahead of the first for a time 2 upon V multiplied by V minus 2AT and its square root. So this is a very interesting question of the relative velocity. So in this case we are given two bodies, and let us call them body 1 and body 2. Okay. And it is stated that, so let us call them body 1 and body 2. So the velocity of initial velocity of body 1, let us call this a u1, will be equal to 0, and so because of that, and it states that after t seconds, okay, you can say that final velocity v1 after t seconds will be equal to u1 plus, let us call this as its acceleration as a, will be equal to a multiplied by capital T, and u1 is 0, so we can say that v1 will be equal to a multiplied by T. And let us say that for body 2 its velocity is given as v2, and it is already stated that it is traveling with a uniform velocity v. Okay. So if you find out the relative velocity, okay, relative velocity of body 2 with respect to body 1, so we get v21 will be equal to v2 minus v1, and if we substitute the values, v2 we already know is given by capital V, and v1 we found out is given as a multiplied by t. Okay, so we can say that v21 will be v minus at. From here we can also find out the acceleration a21 will be equal to minus of a. Next we find out the distance traveled. By body 1. Distance traveled by body 1 in time capital T. Okay. So it means S will be equal to u1 t plus half at square, and u1 is 0, so we can say that S will be equal to half a t square. Okay, but we can also write this distance, okay, but we can also write this distance as, but S can be also written as v21 into t plus half a21 into t square. Okay, so let us call this as equation 1 and equation 2. So you can say that from equation 1 and equation 2 we get half a t square is equal to v21 we already know is given as v minus a t, okay, into t, and a21 is minus a, so minus half a t square. So we can make this equation as a quadratic in small t. So we write t square minus 2a v minus a t multiplied by small t plus t square is equal to 0. And we assume that let t1 and t2, rather if t1 and t2 are the roots of, let us call this equation 3, then t1 and t2 are the times when the displacement of both the bodies will be equal. Then t1 and t2 are the times when displacement of both bodies will be same, or we can say equal. So from we can find out the difference in the roots then, because we have to find out what will the time difference. So difference in roots, which means we find out t2 minus t1, and this will be equal to 4a square v minus a t whole square minus 4t square and its square root, and this can be written as 2a square root v minus 28t. Okay, and we get that the difference in time is equal to this, which was asked by the question, that what will be the difference in their time. Okay, so this proves the question, or rather we can say the thing which we were asked for. Thank you.